Here we're doing section 6.1, problem 3b. The question asks us to factor out the greatest common factor from this expression. So before we can factor out the greatest common factor, we have to find the greatest common factor. We do that in the same way. We find, first of all, the greatest common factor for numbers. So 20 is 2 and 10. 2 is prime, 10 is not. 10 is 2 and 5. Both of those are prime. 10 here is 2 and 5, both of which are prime, and 15 is 3 and 5, both of which are prime. So now we need to find a GCF for the numbers part. So we have 2's here, a 2 here, but no 2. So 2 cannot be a GCF. We have a 5, and a 5. Those are part of the GCF. And then we have a 2 and a 3, none of which match. So the numbers part of the GCF is 5. And then look at the variables. Remember, the GCF for variables is always the smallest power of the variable. So we have m to the 5th, m to the 4th, m to the 3rd. So it's the smallest part, m to the 3rd. So the GCF here is 5 m to the 3rd. The question asks us to factor out the GCF, which means we need to find out if we were to take a 5 m to the 3rd out of each piece, what would be left over. And so we can use this prime factorization tree. So if we take a 5 out of this, that means basically we just remove the 5 from this tree. And we're left with 2 times 2. And if we take an m to the 3rd out of this, we have 5 here. We take 3 away, we're left with m squared. We do the same thing in the second one. We take the 5 away, we cover up the 5, we're left with 2. And we have m to the 4th, we're taking away m to the 3rd, that gives us m. And then we have 15 m to the 3rd. We take away the 5, we're left with 3. When we take away the m to the 3rd, that leaves us with no m's left. So we have this expression is what's left over after we've taken this out. So we need to find a way to combine these together. And so we write that in this way. We put our common factor out front. That needs to be multiplied by what's left over. So we have 2 times 2 times m squared is 4m squared. Then we have 2m, and we have 3. So if we factor out the greatest common factor from this expression, this is what we get. The greatest common factor times what's left over. And if we wanted to check this, we could multiply this back through and come up with the same expression we started.